Here we go. Last part of the example problems, starting with example number 4. All right, so here we go. Solve 4k plus 12, ba-di-bi-di-ba, booty-bi-di-ba. All right, and then graph the solution set. Now, this one says, as you can see, it says overlapping intervals. So let's go ahead and see what this is talking about, overlapping intervals. So you know that you would have to take 12 here as subtraction. These will cancel. That is going to lead us with this right here. 2 minus 12 is going to give us negative 10. And then lastly, we're going to divide by 4, and we're going to get a fraction that if we divide 10 and 4 by 2, right, we can simplify that fraction. We'll get negative 5 over 2. And if you want to see it as a decimal, if you're freaking out and you're wondering, how does that look like as a decimal? Go ahead and divide it. What is half of 5? And that is going to be 2.5. So on this side, we have take 4 to the other side by subtraction. That is going to cancel out these 4s over here. But also, coincidentally, it'll also cancel out these 4s from here. Don't be scared. A lot of people are seeing those zeros and freaking out and going, what do I do from there? Keep going. 0 is still a number. Here, we're going to be dividing by negative 2. It is a negative number. So therefore, we must flip the sign. It's a negative number that we're dividing by. And here we have it. Okay, as simple as that. K is less than 0. Make sure you flip the sign. So here is our final answer. Our answer is where K is a value that's less than 2.5 or K is a value that's less than 0. Now let's go ahead and see that in a graph so we can see what it means for something to be overlapping. All right, so here we go. Let's go ahead and look at the red one first. We have an open circle because of the symbol that we have, less than, and then we have an arrow going to the left because it says K, my K values are less than, so to the left. That's going to be everything in red. Everything in blue is going to be where K is less than 0, all the numbers that are less than 0. Now, what do you notice? We notice that blue is literally overlapping all of red, okay? Blue has its own section, but then it has all of red. Now, what does that mean in terms of the solution? Well, remember that we're still working in OR. We are still working with OR. Here's the word. And that means that it only has to satisfy one of them. Okay, so let's go ahead and look at my green dot. If my green dot is anywhere here on this number line, on this side of the number line, you can see that it's not part of any region. So this will be no solution. This will be a false statement if you were to put any of these numbers into your inequalities. Now, what happens if we put it here? That means that will still not be a solution. It's not part of the red one. Obviously, we're not there yet. And it's not part of the blue one because we're on that open circle. Remember that the open circle means we are not including that number. We're excluding that number. All right, what happens if we are now in the blue part by itself? So let's say that we are at negative 1.5. Is this green point part of my inequality? Yes, it is, because it's part of the blue region. As long as it's part of one or the other one, it's part of the whole function, the whole inequality, sorry. Now, here is where a lot of students start to get confused. What happens if I put it on that open red circle? All right, so we know that once we put it in this blue one right here, we knew that it was not a solution because it was not part of the blue inequality. Now, here, we can say, and we can all agree that it's not part of the red one because it's in the open circle of the red one, but can you all agree with me that we are still in the blue shaded region? This blue shaded region is covered. It's covered from 0 left everything, okay, to the left everywhere. So that means that this green point is part of our solution. It will be good enough. And any number to the left all the way until negative infinity will be part of our solution set. Okay, our set of solutions. That's it. Let's go ahead and take that green point away. All right, so that's what it means to overlap. In theory, we can say that our solution is pretty much, we don't even have to, we don't even have to look at that open circle anymore. All right. What did I do over here? All right. Check problem. All right, so pause it and try it as much as you can. But here, we will take 7 to the other side by subtraction. That will leave us with 12. After we cancel that out. Here, we would divide by 4, leaving us with 3, right? That's going to cancel out. On this side, we will take 5 to the other side by subtraction. The 5s cancel out. That is going to leave us with a -5 on the other side. Now, notice that the m is still not by itself. M has what we like to call a -1 in front of it as the leading coefficient. So what we want to do here is we could divide it to the other side, and that will cause our sign to flip. Okay. Remember that we now have to flip the sign because we divided by a negative number. And there we have it. Our final solution looks like this. Remember to put the word or in between our two inequalities as we had it in our initial problem. Okay. Now, how does this look graphed? Let's look at it. All right. So we have a closed circle on 3. We could see the sign because it's my m numbers are greater than or equal to 3. So we have a closed circle and says I said greater than, that means we're going to the right. So you can see the red shaded region. Please don't look at this red piece right here and think that it just stops right there. Okay. It goes on forever to the right. And then we have another closed circle at the number 5. And it also says m is greater than or equal to 5. So that's why our arrow is pointing to the right. All right, guys, once again, if we can talk about the solution right now, we can say the green dot, which represents a number, any of these numbers that are in this blank region will not make our inequality true. It will not. Now, once I put my number right here, or my indicator right there, which is the number 3, that is when we start getting our actual answers from the answer set of solutions. So the number 3 and anything from the number 3 and anything to the right of 3 will be part of your solution set. All right. So we can say that it's from, you can literally say that it's from 3 all the way to positive infinity. That's it. Good stuff. All right. These are awesome and they work your brain. This is where we have to now grab the graph, right? They already give us the number line graphed, and we got to come up with the inequality that describes this, right? Now, few things we're going to talk about. Okay. We're going to just talk through it for a second, and then we'll put everything together. The first thing I want to talk about is we are at number -2 right here. Okay. Right here, focus on the number -2. Now, whoops. From the number -2, we are looking at the numbers that are, or we're shading, or we're indicating that we are looking to the numbers that are to the right, right? Greater than. So that means that whatever numbers I'm looking at, I'm going to go ahead and put a variable x. My numbers that I'm looking at, my solution numbers, are more than -2. Now, also notice that I do have an open circle that is going to indicate that my inequality symbol does not have this little line underneath. So we're not saying or equals to. And I'm done. I'm done with this one. Now I want to go to this side and say, okay, well, that's my number 4. So I can put the number 4 right here. Very simple. You bring down that number, you bring down that number, and then we just talk about what's happening in between. All right. Once again, we know that we're going to the left, meaning less. I want my X numbers, or whatever numbers I'm looking at, my solution set, to be less than 4. I have right here a closed circle, so that indicates that I can also include the number 4. So I want the numbers that are more than -2, but less than or equal to 4. And there you guys have it. Remember that you can write it like this, or you can write it in this manner. I want my numbers that are greater than -2 and the ones that are less than or equal to 4. There we have it. Okay. Okay. How do I know that this is an and problem? That's the next question. How do I know that this is the word that should go in there and not the word or? Well, we know that because I want you to look at the graph. I want you to look at the graph. Do you guys remember that if we had an or problem, then that means that the solution can be one or the other one. Do you agree with me? Yes. Okay. So if we were to have an or problem, this is what the graph would have looked like. Keep your eyes on the blue and the green right now. And I want you to keep your eyes on the red dot that I'm going to move around. If I put my red dot right here at the number -5, do you agree with me that the red dot is a solution for the blue line? And the answer should be yes, it is. Well, that means that the red dot should be part of our solution. But there's no shaded part here. There's no shaded region. The shaded region only goes from here to here. So the shaded region is only in between. Okay, that right there is pretty much the idea as to why this is an and problem and not an or. It needs to satisfy both of them. Both of them. Right here, we're only satisfying the blue. Whoop. Right here, we're only satisfying green numbers, the numbers that will make the green inequality true. But anything here, anything that is actually shaded that we can see right now, it's satisfying both of them. So that is what's called an and problem and not an or problem. That is how you would know. Okay. All right, let's move to the next one and see if we understood it. Which compound inequality describes the graph? All right, think about it right now. Is this an and or is it an or? Well, the cheat code is that we are in between these two. It is in between these two values. So that is going to be an and problem, So the first value that we have right here is 7. The other value that we have right here is 9. And the solutions that we want are obviously to the left of 9, which is less than 9, but more than 7, right? Look how I'm doing it a little bit more quick, a little bit more smooth, and I'm trying to go with the flow and seeing everything that I'm doing. The next thing that I'm going to take into account is this circle right here is a closed circle. So I'm going to have, I'm going to put a line under this and say, yes, we are including 9. And then this is an open circle. So I am leaving this right here as it is. There we go. This is our answer. We want the numbers that are greater than 7 and less than or equal to 9. Now, remember that there's several ways of writing this. We can write it with the word. So the numbers that are greater than 7 and the numbers that are less than or equal to 9. We can write it like this, and we can also write it in set notation, people. I'll go ahead and write the set notation from our original here because it's a little bit easier and shorter without the word and. In terms of x, my values that I'm looking for are more than 7. Ooh, wait. I tricked my mind there. The values that I'm looking for are more than 7, but less than or equal to 9. Close set notation. Boom. There's all the ways that we can write it. Set notation with the word and in the middle. And that's pretty much it. All right. Moving on to the next one. Let's see what we have. Ooh, all right. Look at what we have here. They are telling us, they are literally telling us that our answer can be located here on this area or on this shaded area. So that means that this is an or problem. It can be on one shaded area or the other one. All right, so let's get right to it. Like I said, obviously it's that shaded region or that shaded region. Anything in between, it's not good. All right. So we know for a fact it's an or problem. So I'll go ahead and put this right here as a nice little reminder. And I'm going to go, okay, well, the first part of our or problem is starting at 8, right? And then from 8 is to the left, which is less than. So the numbers that I'm looking for are less than, we have a closed circle, so or equal to 8. Or the numbers that I'm looking for can be, you can see that there's the number 12. So the numbers that I'm looking for, and we're looking at the numbers to the right, so more than. So once again, the numbers that I'm looking for are more than 12. Open circle, we keep the inequality looking like this, and we're done. Okay. A friendly reminder, when we have an inequality, a compound inequality with the word or, there's no way for us to write it without the word. You either put the word or it's not an or inequality. If it doesn't have an or inside of it, it will be an and inequality. All right. That's it for this one. Obviously, we know that we can write this in set notation. I'll go ahead and just do this. I'll do this right here. This is how it would look like in set notation. That's it. Okay, so that red part are just the symbols that will indicate that this is written in set notation. I believe this is the last one. Yep. Which compound inequality describes the graph? Which compound inequality describes the graph? All right, so here, once again, we have or. We have that side or we have that side. All right, that's pretty self-explanatory. So right here, we're talking about the numbers that are less than, close circle, or equal to number -1. On this side, we are talking about the numbers that are more than, so because we're going to the right, close circle, or equal to the number +1. And there you have it. This right here is our answer. Obviously, we need to make sure we grab our very important word, and we're done. Remember that you can write it like this, or you can go ahead and include our set notation, little symbols, to finalize this. Finito. All right, guys, all done. Make sure you now get to the practice problems that are located in your book. And that's it. Peace out.